The music of the spheres. How did I personally come to know about these electrons and quarks that are believed to be the last layer of my dice? Haha. I've never seen them. If I actually ask myself how I know about them, the answer is that I've been told and read about them so many times that I've actually forgotten why and how I know. Yeah, this is quite often happening to any people, including myself, right? Or come to think of it, was I ever told how we know? Is it a bit like the way I know Everest is the tallest mountain? I know that only because I've been told it enough times. Sure. So before I ask whether there is anything beyond this layer, I need to know how we got to these building blocks. Sure. Reading through the history, I am surprised that it is only just over 100 years ago that convincing evidence was provided for the fact that things like my dice are made of discrete building blocks called atoms and are not just continuous structures. Sure. Despite being such a relatively recent discovery, the hunch that this was the case goes back to the thousands of years. In India, it was believed that matter was made from the basic atoms corresponding to the taste, smell, color, and touch. They divided atoms into the ones that were infinitesimally small and took up no space, and others that were gross and took up finite space. An extremely pleasant theory, prescientist theory, as you will see once I explain our current model of matter. Sure. In the West, it was the ancient Greeks who first proposed an atomistic philosophy of the nature, advocating the reductionist view that physical reality could be reduced to the fundamental units that made up all matter. These atoms could not be broken down into anything smaller, and their properties should not depend on some further complex inner structure. One of the seeds for this belief in a universe made from the indivisible building blocks was the Pythagorean philosophy that numbers is at the heart of explaining the secrets of the universe, right? So because all object is all about the physics and the information, right? Sure. And mathematics is only about information, right? The conviction in the power of whole numbers had its origins in the rather remarkable discovery attributed to the Pythagoras, namely, that number is the basis of the musical harmony that both my cello and my trumpet exploit. The story has it that inspiration struck when he passed the blacksmith and heard the hammers banging out of the combination of the harmonious notes. We can't be sure whether this and similar stories told about Pythagoras are true, or even whether he really existed and wasn't an invention of the later generations used to promote new ideas. This story goes that he went home and experimented with the notes made by a stringed instrument. If I take the vibrating strings on my cello, then I can produce a continuous sequence of the notes by gradually pushing my finger up towards the bridge of the cello, making a sound called glissando. Although a question of the whether this is truly producing a continuous sequence of the notes will be challenged in the next edge. If I stop at the positions that produce notes that sounds harmonious when combined with the open vibrating string, it turns out that the lengths of the strings are in the perfect whole number ratio with each other. For example, if I place my fingers at the halfway point along the vibrating string, I get a note which sounds almost like the note I started with. The interval is called the octave, and to the human ear, the notes sound so similar to the notes on the open string that in the musical notation that emerges we give these notes the same names. If I place my finger a third of the distance from the head of the cello, I get a note which sounds particularly harmonious when combined with the note of the open string, known as a perfect fifth. What our brains are responding to is a subliminal recognition of this whole number relationship between the wavelengths of the two notes. Sure. Having found that the whole numbers were at the heart of harmony, the Pythagoreans began to build a model of a universe that had these whole numbers as the fundamental building blocks of everything they saw on or heard around them. Sure. Greek cosmology was dominated by the idea of mathematical harmony in the skies. The orbits of the planets were believed to be in a perfect mathematical relationship to each other, giving rise to the idea of the music of the sphere. Wow, music of the spheres. Wow. More importantly, for understanding the makeup of my dice, it was also believed that discrete numbers rather than a continuous glissando was the key to understanding what constituted matter. The Pythagoreans proposed the idea of the fundamental atoms that, like numbers, could be added together to get new matter. The Greek philosophers and mathematician Plato developed the Pythagorean philosophy and makes these atoms into discrete pieces of the geometry. Sure. Plato believed the atoms were actually bits of mathematics, triangles and squares. Sure. These were the building blocks for the spheres that he believed were the key to the ingredients of Greek chemistry, the elements of the fire, earth, air, and water. Each element, Plato believed, had its own three-dimensional mathematical shape. Wow, trigonometry, right? Fire was the shape of a triangular-based pyramid, or tetrahedron, made from 4 equilateral triangles. Earth was a cube shaped like my Vegas dice. Air was made from the shape called an octahedron, constructed from 8 equilateral triangles. It is a shape that looks like two square-based pyramids fused together along the square surface. Finally, the water corresponded to the icosahedron, a shape made from 20 equilateral triangles. Wow. Plato believed that it was a geometrical interaction of these basic shapes that give rise to the chemistry of the elements. The atomistic view of the matter was not universally held across the ancient world. After all, there was no evidence for these indivisible bits. You couldn't see them. Aristotle was one of those who did not believe in the idea of fundamental atoms. He thought that the elements were continuous in nature, that you could theoretically keep dividing my dice up into the smaller and smaller pieces. He believed that the fire, earth, air, and water were elemental in the sense that they could not be divided into bodies different in form. If you kept dividing, you'd still get water or air. If you take a glass of water, then to the human eye, it appears to be a continuous structure which can theoretically be infinitely divided. Sure, if I take a piece of lava, then I can stretch it in a smooth manner, making it appear continuous in the nature. The stage was set for the battle between the continuous and the discrete models of the matter. The glissando versus the discrete notes of the music scale. The cello versus the trumpet. Intriguingly, it was a discovery created to the Pythagoreans that would threaten the atomistic view and which turns the tide for many years in favor of the belief that matter could be divided infinitely. Wow, sure.